just small?
There's different types of energy, like gravitational energy is what makes everything fall, like this paper. And there's elastic energy, like when I'm pushing the rubber band, that's elastic energy. Chemical. Friction energy, now we do friction. And like anything you do in the movement, it requires energy. Like when I'm doing this, I'm doing energy. And there's also electrical energy. Everybody should know that one. We're studying this. So there's many kinds of energy. There's more than the ones I mentioned, but cut. Hold up, I messed up.
Okay, let me see your poster.
Well, it's like a falling paper. And are there any questions about this? You, Victor?
No, I'm good.
Okay.
Don't forget to say action.
Sure. Did he say action? Oh, are you recording?
We're ready.
Okay,
We're ready.
I'm ready. Okay, my topic is kinetic energy. Kinetic energy is energy in the form of motion, like a spinning bicycle, a sprinting runner, a runner sprinting, a 4x passing to the pole and going into the golf thingy. But the amount depends on two quantities of mass, a moving object, and its velocity. And right here we have an example of the little car, the truck, and the motorcycle. Kinetic energy of each vehicle is different because kinetic energy depends on the object's mass and its development. Even though the same velocity, the truck has more kinetic energy because it has greater mass than the motorcycle. And right here it's like a formula where you can figure out what kinetic energy is. It's calculated by kinetic energy equals half mass times velocity squared, or the other one. And the more mass an object has, the more kinetic energy it has. Right here I have the examples that I'm doing. And right here, see, I'm gonna put it right here. And where's it at? See, if I go to 6, 9, right here, 9, and I let it go, it's 15. And when I go all the way over here, and I let it go, it goes more further because it has more velocity in it. And so I go right here and I roll it down. It don't knock it down. But I did the volume one?
Mm-hmm.
With the ruler on it?
Yeah, it'll probably work.
Isn't it too heavy? Can you hold it?
I think it's gonna break. If it goes, it's gonna go. And it's gonna knock it down because it has more energy, mass in it. There it goes. And there.
See the story of the car? What we're talking about is potential energy. Potential energy is stored energy that can be converted into kinetic when a force acts on it.
There are three types of potential energy. There are elastic, chemical, and gravitational energy.
An example of the gravitational potential energy is an apple on a tree. That,
Then elastic potential energy is instruction broken.
an example of chemical energy is a battery. An example of elastic energy is okay, go ahead and put yourself.
Yes. Why is that potential energy?
Okay.
Elastic potential energy.
With elastic energy, that's usually anything that you can bend or stretch and it wants to go back to its original shape. So like a diving board, when you bent the wood, it wanted to straighten back up. So when it straightened back up, it had energy, it created energy to do that. Okay. Same thing like with a bow and arrow, it's the wood being bent. That's where the torque's coming from. So when you pull back the string, it bends the wood and the wood wants to stretch back. Okay. So it's not always just something that's rubbery. Most people think it's like rubber or elastic only, but you know, wood is a very common one. Metal, when you bend it, it keeps that shape, but wood will bend till it breaks usually. Otherwise, it will go back to its natural shape. Any other questions? Okay, can we get some scores? Okay, 9. Scores?
Hey, I was gonna ask you.
What did y'all give him? 9.
Like 199.
Okay.
Changing energy. You will be more likely to think of energy as race car, roller fast, or as your body use energy from food to help it move, or as the sun warms your skin on a summer day. You might be thankful for electrical energy as you play a favorite city. These situations involve energy changing from one form to another form. Energy is most noticeable as it transforms from one type to another.
It is an example of energy. Like chemical energy is a gas. It turns into chemical is a gas in its liquid form. And then when this electrical thing, its particle causes it to explode and turns to a gas, which moves the piston down and makes it tire. Any questions?
No.
Last group.
Let's go.
Alright, senior, give him 5.
Yeah?
Yep.
Okay. We're going to talk about conversions between kinetic and potential energy. Main situations involve conversions between potential and kinetic energy, as swing, roller coaster, arrows. To find the mechanical energy, which is the total amount of potential and kinetic energy in a system, you have to look at the next equation. The right way. The mechanical energy is equals to potential energy plus kinetic energy. Here is an example.
potential and low kinetic. When you go here, it gives high kinetic and low potential. With those two combined, make mechanical energy.
And why does it have high potential when it's up at the top? It's coming from
Gravity.
right. And so when it's at the bottom, it has low potential because it can't fall any farther, right?
Yeah.
Okay. But it's built up speed the whole time it was going down, so it has high kinetic because moving is fast, and that's what makes it go back up on the other side. But then that whole time it's fighting gravity. When the gravity equals the kinetic energy, it stops it, and it's the reverse. Now it's going same thing in the opposite direction. Everybody got that?
Any questions?
Good. Fantastic.